Okay, guys, good morning. Welcome back. We'll hopefully we'll finish this first script today and a few things that I need to tell you, and then you'll be ready for your first assignment, right? Whether it's in class or whether I'll just let you take it home and then complete it by tomorrow. Should be good. It won't take more than an hour according to me, but still I'll give you time for it. Okay, so once I have finished everything, and then I'll post the assignment sometime today, or maybe if I have time right away, I'll post it right away and you can start doing it if you have even 10-15 minutes left over. Okay, so the aim of the course, it's a relational database course. It's an introductory course in which you have to learn the CRUD, how to create, read, update, and delete. So excuse me, so you're working with data, and when I say data, I mean humongous data. Excuse me, right? So we'll learn how to create databases, how to create tables, and then how to work with data in the tables. So I'm not sure how many of you did take the time to read about the data types. If you remember, I told you to read about the set command in SQL to see what are these environment variables, and also read about data types so that when we do data types today, you have an idea of what we are doing. Keep in mind, any extra reading or reading beforehand will fetch you bonus marks, right? So if you've done extra and you let me know, or I see, oh, you know more than what I've done in class, I'll always have your name jotted down and you'll always be able to get extra marks. Same with assignments. If you do anything out of what we've done in class and you've tried to find out more and have something more than what I've asked for, you'll always get bonus marks. All you have to do is make a note for me. This is something I found out, or this is something I did extra, and I'll give you bonus marks for it. It's better that you read a little. If you're told to read something, it just takes half hour, no more, no less, kind of. And you can just devote half hour. As I said, outside class, for now, you don't need more than an hour to kind of keep up with class. The rest is, of course, up to you, right? How you do it. The input you give is the output you get. It's the same as computers. Garbage in, garbage out. Good input in, good output out. Okay, so we learned how to create the database. We did one set statement, and that's strict all tables. If you took the time to read what it did, I'm glad. If you did not, that's fine too, right? In due course, when you start using more set statements, hopefully you will go and read about different environment variables, but you know the use of it. When you work on a server in which you cannot control the environment, definitely you cannot control the environment on a server on which many users work, then you, in your own script, will create your own environment. That environment could be related to tables, that environment could be related to updates and deletes, that environment could be related to the engine you're using, and so on and so forth. So there are many set statements, each has its own use, advantages, disadvantages, depends upon what you want to do and what you don't want to do. So that's the set statement. Usually I use that statement just so that it's in your head, so that you know, yes, the environment can be set. How useful is it for me? Right now, not very useful, to be very truthful. Okay. Then came the database commands, in which we learned how to draw, create, and use a database. I again Again, beware that dropping of databases is not a common thing in everyday life. It's not. You don't drop databases every day. An organization will not come and start saying, oh, here, drop. Databases or servers run 24/7 and databases reside on them. They are updated, the tables in them are updated, changed, whatever, but databases are just not dropped. Drop means dead, they're gone, everything is removed physically. Then why did we choose to do it? Because we are running our scripts over and over again. So we can create the same database in the same space. Remember, your databases are going in a particular directory. Every time if you want to change that directory, you're okay. But all your databases are going in a particular directory, and you can't create a database by the same name in the same directory. Makes sense, right? So they have to be unique. Names have to be unique, like your student IDs. They have to be unique. So we are dropping the database because every time we want to start fresh, in the sense that when I rerun the script, and I will over and over again when I do stuff, I just say, okay, drop it and recreate it, because for me it's less than a minute job. But in the real life, it takes hours to recreate the whole thing, right? So we do that, but again, it's just a statement that you should know. It is a statement that you will write in all your assignments, because you will need to rerun your scripts, and then I will need to run your script again. So we'll keep it there. Do we always create databases? No, not again. Our database may already exist and we may just want to use it. And therefore, we don't always create databases. But again, you should know how to create a database. So the drop command has the syntax drop database and the name of the database. I have chosen to say if exists, because it will not even exist when I run the script for the first time. So I've written a new script, I say drop database, but it says there is no database by that name. So what are you trying to drop? So therefore I say if exists. So there is an if exists, there is also an if not exists, just for your information. So the second run, so I get a warning for the first time. I don't have anything to drop. That's fine, it's a warning, we can ignore it. We can't ignore all warnings, but this one, read it and it just says, oh, it doesn't exist, which is fine. And then we do it. Then we create a database because we need to use one. And all we do is we give it a name. I'm following the conventions of creating my databases, prefixing it with DB for database. It's not a rule, it's a convention. And also I'm using the convention where I'm doing an underscore for my names. So I'm not using the Java naming camel case conventions in my naming. This is more common in the SQL world. The rest I leave to you. You can follow either the Java naming convention or this convention that I'm following of using underscore, but be consistent. Whatever you use, be consistent, okay? And then of course the use statement is important. You cannot work with a database till you use it. So maybe many a times in the real world, you will only be doing statement number 15 because that's what you're trying to do. You're trying to use a database. Now, a relational database is nothing but a collection of tables or relations. Therefore, it's called relational database. And each of this table, you can kind of think of it as a block, as a two-dimensional array with columns and rows, right? So it has some columns. Who decides the columns? Of course, the client and you decide. So when I say you could be the designer and the programmer. So you kind of, it's not one effort. It's the client says, this is the information I want to keep about my entity. And then you say, okay, if that's the pieces of information you want to keep, those become your fields or attributes or columns. So our next job is to create a table in the database. An empty database is of no use. So you could create as many tables as you like in a database. As many, really doesn't matter. For the first half semester, we'll work with the single table because we are trying to learn it. And then onwards, we'll start working with multiple tables in the same database. So now I started creating a table. I use the create table command, and the create table, as the name suggests, as the command suggests, which are very English-like in SQL, I'm creating a table. Just for your information, I don't need it because I'm dropping the database. Everything is dead before I start. But just for your information, there is a drop table command also. Same concept. So if you were working in a database, you don't want to drop the database, but you want to drop a certain table, you can say drop table if exists and the name of the table. So that statement is a valid statement. So for me, it's absolutely useless because when I start my script, my first statement says drop the database. So if the database is dropped, everything is dead, right? The tables are automatically dropped. So I don't need that statement. But on a server environment, you should know that you don't drop databases. But if you would like to drop a table, that statement does exist. So in its easiest form, it's drop table and the name of the table. If the table does not exist, it will give you an error. So I say if exists. So if exists means if it is in the database. And the advantage is if it does not exist, I'll get a warning. And if it exists, it will just drop it. So I'll never need it. It's absolutely useless for my code because I drop it. I drop the whole thing before I start. But I'll leave it for you so that you can see. Please see, I comment my code. And I would like you also to comment your code always. So for me, this statement is basically really, really useless. I forgot my semicolon here, and therefore you see a squiggly here. So while you type, if you're making syntax errors, you can know that there is something wrong, right? That's a syntax error. And you'll say, what's wrong? Because you forgot your semicolon here. That's what is wrong, right? Because statements have to be terminated by a semicolon. So that is what was wrong. So, and that helps you. That way you don't have to kind of say, oh, like, let me execute my script. If you can see red squiggly lines, if you can see crosses, definitely your script will not run. So when you give me a script, when you do an assignment, when you do a classwork, your scripts should run. That's the first part. If it doesn't run, I'm not even looking at it. Like, I'm done. I don't know. You're not giving me any answers. If it runs to a certain point, you will get marks till that point. But after that, I can't see anything. I'm not giving marks. So I'll mark till what I see. It's as simple as that. If I see output, I give you marks. If I don't see anything, I'm not going through your script to find out the errors you made. You find out what you made. And if you can, then you ask for help. But don't give me scripts that don't run. Because once it stops for me. Right? The aim is that you learn, but if you make mistakes, I can give you feedback, but I can give you marks for it. So I can give you feedback. This is where you went wrong. This is what you should have done. Or usually what I do is I give the solution back. So after the submission date, I give the solution. Then you can double check. Oh, this is where I went wrong. So that way for every student, I don't have to say, oh, line number 5 is wrong. Line number 8 is wrong, which is a lot of work. Doesn't make sense. So you will usually have the solution from me after the due date. Okay, so that way you can always double check if things are doing okay. Okay, and so we started creating our table. The create table command, simple. It says create table, the name of the table. Again, I am following my conventions. My table names will start with TBL and the underscore to differentiate it, kind of break my words. The TBL is just again a convention followed by many programmers, but again, some programmers don't follow it. I leave it to you. You do what you like. Naming conventions, I'll stick to the underscore. You can use Java naming convention, but you have to be consistent in your code. In one script, you do one kind of convention. Don't mix and match. That's untidy, so you're not following conventions. And again, you will have marks for, did you follow conventions in your code? So we said, okay, what fields do we need to put in the table? So the fields that I was putting in the table is what I collected from you. So if you remember last week on a sheet of paper, you had given me some information about yourself. So I'm trying to say, okay, these are my fields now. These are my columns or the attributes, or this is what I would like to save about my entity. So we talked about student name. All of us agreed that student names are strings, right? They're not numbers, of course. They're not Boolean values. So we said they are strings. And if you remember, I had shown you that there are different kind of strings. Again, I don't know how many of you did take the time to go and look at the manual. And again, it's up to you. It's entirely up to you. You have to make some effort too. If you don't, that's perfectly fine. If you choose not to, that's your business, right? So here are the string types. And then there was the char and the varchar, the binary and the var binary, the blob and the text. the enumerated type, like in Java, where you can kind of say, oh, names of months can be enumerated because they're kind of fixed, and you don't want to make it varchar, because your month names, if I say varchar, then somebody could make up a month called supporter. You know what I mean? So when you know that the data in is kind of fixed and you would like to kind of group it together, it's called an enumerated data type. So days of the week, months of the year, yes, no, like you could kind of create your own set, and then you can say values chosen will only be from this particular set. So enumerated data types can be created. And how you create them, you will learn them. You can always look up before, if you would like to do it in an assignment before I do it, or whenever I do it, I'll show it to you, most probably next week after you do your assignment. So this is what I chose. I went with varchar for the simple reason that I said, oh, names can be of various sizes. So I didn't go with char because char was a fixed size data that is given for every record. And I chose not to do it because I said names are of different sizes. So why should I waste space in different records? A record may only take 10, another record may take 20, another may take only 15. So to kind of save space, I go varchar. So varchar says that the data in can range from 0 to 50. So you can have an empty string in it, or you could have a string of size 50 in it. That's it. No more than 50. If you try to put something bigger than 50, it will tell you that there is an error, right? That's what it does. Or in some databases, it could just truncate it. So you always double check. When you insert records, you can always double check. How is my database behaving? How is this relational database, MySQL, behaving, for example? And then we went to student age. What about student age? Is it text or is it a number? Number, right? Ages are usually number. Now, sometimes it may happen that it sounds like a number, but you may not need to make it a number, like a phone number, right? Like a phone number, like your student IDs, which are numbers. Now, these are those kind of numbers with which you hardly ever do any math. You don't do any math with your student ID. I don't say, is one student ID greater than the other? Are they equal? You know what I mean? You don't do any math with it. Similarly with phone numbers, you do things like extract the area code maybe. The first 3 digits are my area code. You would like to extract them. Sometimes in phone numbers, you also put dashes and round brackets, which of course, it's not a number anymore. But some data sounds like numbers, but even then you choose them to be varchars or chars because it makes more sense. With age, I can, if I like, if I don't want to do any math with it and I just want it for display purposes, just for information, I could have made it a character of, say, 3, because I'm assuming nobody lives more than 999 years, right? But my aim is to show you a different data type, and age usually is good enough to be an integer, right? So it will be an integer. No, it's a whole number. You don't talk about ages as 4.6. You always say I'm 20 years old or I'm 50 years old and so on. So if we have an age, that means if we want to choose a data type which is of type numeric, we have a few options, right? You'll say what few options? Like in any other language. And itself in numbers, we have integers, we have fixed points, floating points, bit values, and so on. And of course, we'll go with integer types because ages are integers. And now itself in integers, you see that you have a few options again. Now the question is, which one should you be choosing? I don't know how many of you remember it from your math class, but the size of your data type will kind of determine what you can save in it. For example, look at the tiny int. Tiny int says I take 1 byte for storage. My minimum value that I can store in it is -128. The maximum value that can be stored in it is 127. When you don't give it a value, I'll give it a 0. But if you want to put only unsigned values in it, the smallest unsigned value is 0 and the maximum is 255. There is no magic in this at all. The formula was simple. If you remember it from your math, if you remember it from your math days. If not, I'll write the formula for you. Uh-oh. seems like no, I have one. Okay, so if we have n bits, right? If we have n bits in a storage area, so let's take tiny int, which is 8 bits. The simple formula is this: the lowest value you can save is 2 to the power of n minus 1. And the maximum value you can save is 2 to the power of n minus 1 minus 1. Now what is this n? N is the number of bits of storage. So if n is the number of bits, why did I do an n minus 1? Because I keep 1 for the sign. Numbers can be positive or negative. So if it was a 1 byte storage, as it is, this goes for the sign bit. So how many am I left with? 7, which is n minus 1. So that's the smallest number you can save in a tiny int, which is minus 2 to the power of 7. And on the positive side, you can save one less number, just because 0 is a positive number and it takes that 0 part. So same on the negative side, same on the positive side. So the smallest number you can save is minus 128. That's what it says. And the biggest number you can save is 127. That's your range. So in terms of ages, is that enough for us? Of course, nobody is a negative age. So maybe we can do better. We should make it unsigned. I don't need it. You'll say, how does it matter? It does matter. One, the range increases. I'll show you why the range increases. If the sign bit becomes a part of your data, then your lowest value is 0, because you don't have to save negative numbers, and your positive becomes 2 to the power of n minus 1. You'll say, oh, n minus 1 was here, we have an n, what's the big difference? You will see it doubles up. So the range becomes 0 to 255. So there is a difference, right? So one, a few things. Will I choose a tiny int, a short int, a medium int, or a big int? One, that's your first decision you'll have to make. You have to think very carefully when you choose your data types in databases, because you're taking up space, and we're not talking about 10 records. We're talking about trillions of records. The college itself has around 8,000 students, and maybe all over the campuses, all campuses not in Berry, but all Georgian College campuses, you could be talking about 20,000 students. You think, oh, that's a small number, but why? I mean, it's not a small number if you start thinking. If I only need 1 byte, why would I give 4 bytes to the age? So I choose to go tiny int, and further I choose to go unsigned tiny int. The range becomes 0 to 255. I don't think there is anybody who lives longer than 255. You can Google it and see if somebody has, but that looks good enough to me. And definitely I know that age cannot be negative. So the data type to be chosen, and whether it is signed or unsigned, you will have to think about it, and it will carry marks. I'll always say, please use best fit data types. It has to be the best fit, right? So if you want to put something, if you want to just place a pair of shoes, you will choose a shoe box. You won't buy a big box to keep a pair. So you have to think. A little Levi here or there, a little padding is good. I need 1, I'll go 1.5 maybe. You know what I mean? A little padding is okay, but when required. For example, in name, I went with 50. I could have gone 62, not too bad, but I wouldn't have gone 200. Nobody's name is 200 characters long, right? So little padding is okay. Here, why would I go small int? The small int says the maximum age is 65535. Out of question, like nobody ever will need that age. So 0 to 255 is a good range. I think we all agree on that, right? Anybody who's heard of somebody living beyond 255 years? Google it if you like. I don't think so. So what will I do? I will say that my student age is a tiny int. So again, only an int will not do. I would like to choose the best of the ints. And further, I would like to say it is unsigned. So by default, it is signed. Signed means it can be negative and positive. Then my range is smaller. My range is minus 128 to 127. And yes, people can live. I think 134 or something I read last. Somebody was 134. So that won't work for me. But I won't go to small int. I'll still go tiny int, but I'll go unsigned with it. And going unsigned makes sense because ages are only positive and it gives me a range from 0 to 255. I'm good with it. So will I lose marks if I don't choose the best type? The answer is yes, because there will be in your assignments and in your exams or tests, there will always be in, please choose fields of best fit. Why? Because I want you to think that way. I want you to think, oh, can I? Should I? Otherwise, you'll be careless. Many of us are, right? If it works, we say. But it works perfectly is what I want you to think. You're programmers. You're not casual programmers. You want to be programmers in your profession. So please think intelligently, right? So that's what I want the age to be. Makes sense to me. Tiny int, unsigned is good enough. Let's go to the third field. The next field that I asked for you was student email. Please keep in mind that the sequence of how you're writing here as such is not important. Theoretically, it really doesn't matter because you refer to columns by names, not by positions. So I could have easily taken this student email for whatever reason. I'm just kind of showing it to you. And I could have placed it here. And that doesn't change the structure of my table in any way. Yeah, when you insert records in a particular way, then we have to be a little careful. And I mean, there are options there also, but otherwise it really doesn't matter, right? So let's go with student email. What data type do you think will work for it? Let's hear. What data type for student email? Number? Is it a number? Nope. So it's character, text. Are you sleepy? I don't think. I think you can say yes or no or varchar or numbers. If you don't interact, you won't learn. But if you don't want to interact, let me know and I won't ask questions. Why waste my breath, right? Again, I'll go with varchar. Again, I don't go with character. Why? Because I don't want to give it a fixed length. Because I don't know what kind of length will it be. Again, it will vary, right? So I don't know. What do you say? 70, 75, 60? Usually emails are not longer than that. I mean, I think we are good enough. Like, as I said, you can choose whatever you like. It really depends on you. Even 50 sounds good to me. Again, there. Right, so the sequence in which you're writing your fields is not very important. It's not important. Theoretically, it's not important. Practically, behind the scenes, we don't know how it does. Does it really keep them that way in the table? We don't. It doesn't bother us. Why? Because if we want a field, we will call it. We'll say, oh, show me the student name. Show me the student email. I won't say, show me the first field. Show me the second field. So the position of columns and the position of rows basically is not important. You could insert rows or data in a certain order, but when it comes up and you display it, it may not be in the order you show, unless you sort it. So if you always sort it, then always it will be in a certain order. But otherwise, it is theoretically written in manuals that the sequence of data, column-wise and row-wise, is unpredictable, right? You have no clue what it will be. Usually it's not that bad. Okay, so that was my third field. Then I had another one that I said semester fee. What about semester fee? Is it a number? Yes. An int or a float? A real number or an integer? What would you like to choose for it? I hear integers, but in the data that I collected, I did see floats also. I saw numbers like 0.50, 0.71. I did, right? So again, you will say, how do I decide? You will know, you will have an idea of the data. Your client will give you an idea. You're not kind of making something up in the air, right? So if I was making something for Georgian College, I would kind of ask in the registrar's office, what is the fees range? What do you do? Like, what kind of fees is it? They'll say, oh, something like $3,000 and maybe 50 cents and so on. So they'll tell me, yeah, money is involved. And in money, you could be talking fractional money, right? Though integers would be better, easier, because we know that integer arithmetic is easy, but that doesn't mean it's easy, so we don't do the right thing. We need to do the right thing. Having said that, and again, if you had, again, done a little bit of research, as I said last week, you will notice that there are two types of floating numbers. One is called fixed point types, and it says exact value in it, and it comes in two names, decimal and numeric. And there is the floating point type, which says approximate value, and it again comes into float and double. They're of different sizes too. Float will take less space, double will take more, numeric and decimal are bigger. But the difference between exact and approximate values, normal English words. Exact means if you're going to deal with such kind of numbers that in which precision is important. Right? It is important that the values be exact, like money, monetary values, right? Or you're writing an application for some aviation, which is important, right? Then you would go with the decimal or the numeric type. Same thing, decimal and numeric. You'll say then Y2. Can't say Y2. MySQL just chose to do 2. Maybe Oracle doesn't even have the numeric, it just calls it decimal. So again, relational databases, their names could be different, but their features, you'll have to read the features always. And the other one is kind of approximate values, where you're kind of talking approximately, right? So if you would like to say, maybe I'm talking distance, and I would say something in 5.6 miles, I'm okay. It doesn't matter if I say 5.67 or I say 5.68, like it's okay, it's approximate value. There is where you can choose the float or the double. Floats are smaller, they take less space, doubles are bigger, their ranges are bigger, they take more space. Again, you could go signed or unsigned. So it has been mentioned that for fixed point types and for monetary data, try to go choose this type. It's already there. And look at the format. They've given an example. They've said decimal. You can use numeric also, the word. And then come two values. There is a value and a comma and a value. And I'll talk about what the values are. The first figure is the precision. The second figure, the scale. Again, you did this in math in computer industry in your first semester, but I'll repeat it for you as if it was a layman language. And notice, if it is 5,2, the minimum value I can save it in is 999.99. That's 5 digits in all, 2 places after decimal. And the maximum value I can save is 999.99. Again, that's 5 places in all, 2 places after decimal. So that tells you, oh, the first is the total and the second is how many do I need after decimal. We don't count the decimal point. So 5 is the total, 2 after decimal. That's how you use the decimal. You'll say, what if I don't want to? So there is a syntax. You can only say decimal M. But then that means you don't need any places after decimal. So if you want to go that route. But usually if I want to use decimal, I would like to have, I'm choosing decimal because I want something after my decimal. Otherwise, why wouldn't I go with an integer? But there is an option. You can just say decimal M and it's decimal M0. It's equivalent. So similarly, the syntax is equivalent to decimal M, 0, where the implementation is permitted. So you can read about it. So what do we want? So we want a decimal number for sure. Why? We could have chosen float and doubles, but they are inexact, approximate values. And it has been quite clearly mentioned, though decimal takes much, like the byte size is bigger, we may not even need it. But for semester fees, it doesn't go in lakhs, like it doesn't go in thousands and thousands. But it's recommended that when you work with exact data, you go that route. So I choose decimal. I want to go unsigned, of course. But now the question is the space. So you choose what you want. Let's see. If I choose three, like maximum 3, which will say $999, doesn't work. Let's choose 4. 9999. Anything more than 9,999 in semester fee? I think international students pay a little more, right? So let's go 5. So 5, total 5, right? So I'm talking 5 in terms of before the decimal. So how many after decimal in money? 2, no more, no less. We don't go less than 2, we don't go more than 2. It's just not permissible. It's incorrect. So 2 after decimal. So 5 before decimal, 2 after decimal makes a total of 7. So my first figure should be 7. I won't go 8. I've already done 7, which is more than enough. You know what I mean? Like 5 before decimal is more than enough for a semester fee. So I've done my padding already. So when I say 5 before decimal point, that's what you're talking about. I don't think we have a semester fee more than that. 100,000. I don't think so. At least not in our college, right? We are talking semester fee. If it was yearly or if it was program, then I would have thought a little differently. We are talking semester fee here. So depending upon what we need. So you have to think, do I need, am I okay with 999 as my maximum value? The answer is no. Am I okay with 9999 as my maximum value? I will say no because of international students, right? So I go one further and it takes me to that. So 5 before the decimal point, 2 after the decimal point, total 7, and 2 places after decimal. That's what I would choose for a semester fee. So now you know the decimal also. So there is decimal, there is numeric, there is float, there is double. There is tiny int, small int, medium int, long int. Who'll remember all this? You. Right? But you don't have to memorize it. You can always look it up because the manual is available to you. Right? You can always look it up. You can always go look up something like what works best for money, and you'll have answers. But to caution you, during the exam, if you are doing a hands-on exam, you will be allowed to use the manual only. You can go looking for answers on the web. So it will be monitored. But manual is fine. There is no problem in manual at all, right? Because the manual is just like a help book, okay? And if you have a textbooks will be allowed. And of course, whatever you do in class will be allowed. So if you're doing stuff in class, you're doing your assignments, you're following me, you're not busy on your phones, then you should be okay. Okay, so I chose to go decimal 7,2 and I said unsigned. Sounds good? Looks good? We are okay? Everybody satisfied? Okay. And you can always say, no, I'm not, and then we can always discuss it. And then I asked for job desired. Now here was a little bit of job desired. Does she mean one? People could have one preference. Some had two, I saw. I could have three. I could say I want to be an application programmer. I would love to be a database designer. I don't mind that at all. And I love working on mainframes also. So I could have more options, right? Or as job desired, I would like to be a professor, which I am, right? So I could have more than one job desired. So the clarity, there wasn't much clarity in it. So where does this clarity come from? It comes from the front end. When you collect data from the user, right? When you collect data from the user, you may give maybe 4 boxes. Job, your first preference, your second preference, your third preference, no more. You're asking for the first 3 preferences. Then you know, oh, I can make 3 fields, preference 1, preference 2, preference 3. Then you can do that. But right now, at this point of time, I didn't say anything. So you'll have to make an educated guess. Of course, we'll go varchar, right? And I don't know, what about 100? Looks good enough? 3, 4, 5-ish, maybe 150 if you go to 5. I'm kind of giving 30, 40 each, which is not bad. But again, I could be wrong. So there is no rule which says, oh, that's all it is. And again, as I said, designing is a big issue. Before you program, you design, and you design well, right? If the foundation is good, if the design is good, buildings don't drop, bridges don't crash. So if they were not designed well, then that's what happens. Cars are designed. Cars in India are different from cars in Canada because of weather conditions. So everything is designed first according to what is required, and then they are created. So you have to design things well. So that's my thing. You could change it. You could go, oh, I want to go 150, no big deal. But don't go 500. Doesn't make sense to me. Okay. So again, think. And the last one was favorite sites. And again, it would be a varchar. I don't know. I could go again 100 or 150, and that looks good enough to me. No, there is no comma after the last field. But notice how all other fields have been separated by commas. If you don't, you'll get a syntax error. See, you get a syntax error. So at most of the times while you're typing, you will be able to find out something is wrong. And usually the error will be not on the line where you see it, it will be a line above. Because What's causing it is you come to something and you said, oh, I didn't finish my previous one. So don't forget your commas. But there is no comma after the last one, right? Try it. I think we should have a syntax error. Or maybe it is allowed and you just can't. No, it's not allowed. Okay, so no comma after the last one. But there is a semicolon when you finish off your create table command, because semicolon says my statement has terminated, finished, I'm done with this statement. So there my table is defined. How you write your fields in the order doesn't matter. The names matter. Personally, the names matter. I don't want you to call them ABC 1, 2, 3. And the types definitely matter. What you choose, the type you choose, the size you choose, it matters. Okay, so you can always look up to see what are the various types that are available in MySQL and what would be the best fit for my particular data. So let's try to run it. Let's see, what did we do? Let's try to run this. Refresh on the left hand side. Open your DB College. Tables has an arrow now. Before there was no tables, didn't have anything in it. But now there is a table called TBL students and it has some columns. And those are the columns you define. There are indexes and foreign keys and triggers. Triggers is an advanced course. Foreign keys we will work on after the half of the semester. Index in a layman language is just an index, as you say in English. It's called an index that if you sort the data, it is an index that helps you to look at data. So it's basically when you sort data, when you sort your data and you say, oh, I want to sort it on my student name, an index will be created on student name. Why? Why are indexes important? Because sorted data is always easier to search. We know that, right? Dictionaries, phone books. If you have to look up for something, you kind of say, oh, I have to look up for a word that starts with W, wholesome. You take your dictionary and you kind of don't start scanning it from the first page. You never do that. Though we don't use dictionaries anymore, paper copies are out of fashion, but still, you kind of say, oh, I know where W will be. It will be towards the end. So you kind of do a binary search on it. Binary search says every time break it in half. Binary, bi means half. So you kind of, if you wanted, you could take your dictionary, open it in half, right? And then you know that W is more than that half. So you'll go to the second half and again, open it into half. Then you can look at that half page and say, oh, W is still on the right. Go to the second right and again, open it into half. That's how you work. It's called binary search. It has been proved mathematically that binary search takes much, much less time than a sequential search, which is basically what? The first page, the second page, the third page, and fourth. That's called sequence, right? So if you create indexes on your tables, which you will again learn to do it in the second semester, when you do your advanced course to how to create an index, so it's not a big thing, it's create index. You're basically saying that I want to create a kind of, like what you have at the back of your book. If you look up a word, it tells you on what page you can find that word. So it kind of creates an index. What do we call it? We call it an index. So I can't find any other word for it, right? So it creates an index for it so that when you say search for student ID 100, it goes to that index, says, oh, 100 is sitting in that place on my server, and it kind of makes that rule, right? So indexes are created and so indexes are useful. So you will learn hopefully how to create them in part 2. We won't learn it, but by default, indexes are also created on primary keys, which we'll talk about later in the day today. Okay, so we will talk about primary keys. My table is ready. Now my next step, data. I have to put data into my table. Otherwise, what will I do with an empty table? So now let's learn how to populate the data with table. Let's populate the table with student data. Now, definitely there has to be a command. And as we've seen, they are so English-like, it won't be so difficult. So the command is insert into. We are trying to insert into. And of course, insert into what? The name of the table. Now this is a feature I was talking about, why I like to do my tables with TBL starts. Because when you do this, all your TBLs will come together, right? So it's easy to kind of, if you forget, you don't remember the table names, you know it's called table student kind of or something. But then you don't have to worry about spellings or was it student or students or what did I do? I mean, it gives you a good idea. It's like IntelliSense and you can just choose from here. So that's the reason I kind of choose that convention of naming my variables in such a way so that when I start typing, I can choose from a list, which we all know is helpful. All smart environments give you this option. Okay, so I'm going to insert data into this table. What values will I insert into it? So this is inserting data into the table, and this format that I'm using is by default. So this is the most simplest one. I'm not mentioning any fields. I'm not saying, oh, I'll enter name first, I'll enter email second. I'm not saying anything at all. So by default, by the default of this insert statement that I'm using, you will provide, you won't say provide, how many fields do we have? 6, I think. 6 fields or columns, whatever you would like to, for every record. You can go columns and row if you like. And you have to ensure the order of the fields match the structure of the table. You know the class starts at 8, right? So after today, everybody, not only the student, everybody, because somebody else also came late. The class starts at 8, the doors close at 5 after 8, and you don't open the door. I won't let you in. It's as simple as that. It's not an online course. If you're not interested, don't come to class. I don't mind it. It doesn't matter to me. My job is to teach students who are interested in learning, right? So the class starts at 8. If the weather is fine, there is nothing wrong in the weather, that you haven't had any kind of problem, personal problem when you were coming to work, you are not coming to my class after 8:05. I hope that rule is understood by everybody, right? In that case, it's just you're out. You don't have to be here. It disturbs me, it disturbs my students, and it's not respectful. If you don't want to attend classes, don't sign up for them. And then at the end of the day, what will happen? You will miss assignments. You will resort to cheating. You will get a 0. You will fail the course, and you'll all blame it on the teacher. And it happens. I know it. I've been teaching for 30 years now, right? So if you want to learn, please see that you're here on time and don't disturb me while I'm teaching. If you have any issues, please go and talk to the dean about it. Okay, but that's my rule. That's how I work. And it's my class. Okay, so I'm going to insert some values into the table. And please notice I've said by default, provide 6 columns for every record and ensure the order of the fields matches what you've said in the structure of the table. So this is the structure of the table. And notice it's name, email, age, fee, job desired, and favorite sites. Some programmers don't prefer it. They say, I can't remember it, which is okay. Then you make your own list, right? And I show you how to do that. But to begin with, we'll say match the field list. Maybe that's better. Okay, so it's not yet complete. So don't worry about that red squiggly right now. It's not complete. So put your first record in round brackets. And the order in which you give your data is important. So first is the name. Please ensure that text data is written in quotes and numeric data is written without quotes, though MySQL is okay with it. You can put numeric data in quotes as long as it is numeric. I mean, you can put Anju and say it's numeric. You can put 12 in quotes and it will work. But again, the rule in my class is text data in quotes and numeric without quotes. I'll show you. It will allow me to do either. I may forget the quotes in text data, but it matches. It says, oh, you've given me Anju and you've told me it's varchar, it's text data. Or you put 12 in quotes and you say, oh, you've said your age is 12, so I'll take it. But I don't want you to go into that bad habits at all. It's not good programming practice at all. We never do it. Have you ever tried it in Java? No programming language, no good strict programming language allows it. MySQL is kind of loose in the sense it was made for a common, they necessarily database programmers are not hardcore programmers. So they kind of left it simple. So they said, okay, that's okay, as long as you understand. But I think we all understand that text data is strings and numbers are numbers. So let's treat them as they are, okay? So that's my name, that's my first record. I have to remember, then comes my email. I'm using single quotes, you can use double. Both are allowed. I choose to choose single quotes because it turns it green. It becomes color coded. And that way I know that I'm doing the right thing. Like I'm not missing any quote or anything. Try black and you'll try the double, it just goes gray. So it's difficult to kind of see the beginning and the end. You can do it if you like, nobody stops you. But again, be consistent. If you're going to use a double quote, use a double quote. And you can mix and match, that you start with a single, close with a double, and so on. You can do that. Okay. That's my email. My third was my age. Now you could put it like this. Right? You could put it like this, but I don't want you to. And it will be a rule. So I'll go 50, not telling you my age. 50 looks a good figure to me. Right? And then comes my semester fee, of course, which I don't pay, but I'll go 1, 2, 3, 4. I'm a student, right? Now I didn't put anything 0.50 or anything. That's okay. I don't have to say 0.00. When it is saved, it will automatically save it as 0.00 because I've said I need 2 places after decimal. And then comes job desired, and my job desired could be more than one. So I would like to be an educator. And now I have more than one option. So you can separate them by commas, by blanks, by tabs. It's just text, right? Whatever you like. You can put a comma, you could put a semicolon, you could put a colon, you could put a blank, whatever you like. I would also like to be an application programmer. Right? I mean, I don't mind to be a database designer. And I could have more options, but I'll stop at this. So notice that everything has gone in single quotes. It is a field. It is a single field, but it has more than one values. So since it has more than one values, I chose to separate those values by semicolon. You could have chosen semicolon and comma, semicolon and comma. Now you have to know, because it may happen that I extract this field and then I break it up. It's a string, right? And we know that there are many string functions. So I could take it and I could split it on the semicolon and comma. Now this is not the best of the designs. There is a major flaw in this design. It is recommended, highly recommended, and this is the first rule, that your fields should be atomic in nature. Atomic means cannot be broken down or need not be broken down. You shouldn't be seeing repeated data in it. This is repeated data. You say there's nothing repeating. It is repeating. It's the same kind of data. I'm telling you the jobs that I desire. Now, when we talk about the address, now there I say something like 1 Georgian Drive, Barrie, Ontario, Canada. Like now that's not repeated data. You know what I mean? Like one is telling you that the number is 1, then it's telling you the street, then it's telling you the city, then the province, and then the country. But if your application wants that the address must go in different parts, in different fields, for whatever reason, it may be important, then we'll put them in different fields. Street number, city, province, country. And it happens when you fill up forms, some forms will give you that options that you have to put them differently. So there will you say that the data, is it required or not? Therefore, I say that the data must be atomic in nature, cannot be broken down or need not be broken down, right? An address is a good example. A pizza guy, a pizza shop doesn't bother to put it in different. He has a database in which he keeps his customer information so that as soon as you call, he says, what's your phone number? And he can look you up. He doesn't have to ask your address every time. So for him, something like 1 Georgian Drive is good enough, because pizza in Barrie is not going to serve somebody in Toronto. You know what I mean? Like, they don't need to. But a bank may require that the address goes in parts, right? So you could have a house address, then your city, then your province, and then your country, because it's catering to people all over Canada, or maybe Canada and US, or maybe all over the world. So it is important. So the first rule or the first design issue that you must be aware of, which is called the first normal form, 1NF, or the first normal form, says that all data must be atomic in nature. All fields must be atomic in nature. Or in other words, there should be no repeating data in a field. So please be careful about that repeating data, what repeating data means. And when I say atomic in nature, I could kind of add in it atomic in nature. It may or may not be required. So it also depends upon your application. But atomic means cannot be broken down. But in an address, if I put a whole address in one field called address, you'll say, oh, that's not atomic. It has a street number, it has a city, it has, and so on. But keep in mind, it's not repeating data. So more than saying atomic, they've chosen the term that every field, no field must have repeating data in it. The nature of the data must not be repetitive. So we'll learn how to do that. Right now, we have just started. So this table is not the best of the table, right? And it also says that you must have a primary key in your table. And we'll talk about primary key in the second half. Primary key is that field that uniquely identifies your record in your table, like your student ID. Right now, there is no student ID. I took student name. You'll see your student names are also unique. I won't agree with you. I have students with the same name, right? You'll get, oh, but their last name could be different. No? The chances are still there. The probability, even if the probability is 1%, the probability is still there that there are 2 Anju Chawlas in the college. Okay? Okay, so that's my first record. Last still to go. So let's add the last field. It says, what are your favorite sites? Now you can choose your favorite sites. I'll just go google.com. Again, I'll use the semicolon and a blank. I'll go something like lynda.com. Again, I like the CBC site. So you can add whatever you like. I'll just kind of stop here because typing is not a very wonderful job to do. And I put a comma here because I'm going to add another record. When you're done adding all your records, you put a semicolon. So you can add one record at a time. You can have one insert statement adding one record, or you could have an insert statement adding 10 records. Doesn't matter. It's your personal preference. You could be writing insert 100 times to insert 100 records. Or you could be writing insert once to insert all 100 records together. It's a personal preference. Some programmers like to have a single insert statement doing a job. Really, it's not a rule, whatever you like. Okay, so if you go and look on databases or look for tables on the web or look for scripts, you'll see different natures. So what I'm going to do is I'm going to, just for the heck of it, add another one. I'll take Ross Bigelow, since that's another guy you know. I don't know. I know what is. Okay, let's go Ross Bigelow. You know his email too, in case you don't. Right? Should make him old enough 75, but I'll be kind with him. Let's give him 40, right? And he's paid some semester fee. Maybe he's doing more courses than I am. Let's give him 3,050 cents. Just to show you that I'm doing some 50 with it. I'm not sure what he wants to be, but definitely he's an educator. So maybe he wants to be an educator, but I also know that he wants to be an entrepreneur. And spelling is wrong. Definitely spelling is wrong. And the best way to kind of look at a spelling is, and I would like you to always see that your spellings are always right. You can always kind of open it in. Spelling is wrong. Okay. What have I missed? Entry. Oh, okay. I see. I thought it looked okay. There is. That's what I missed. Entrepreneur, not entrepreneur. You say entrepreneur. So I know he wants to be this. I mean, he is. So let's give him this just for the heck of it, right? And I'm not sure about his favorite size, but he's always working on banner because he's a coordinator. So we'll give him banner, right? And I don't know, but maybe Google is everybody's friend. So I'll give him Google too. And there his record ends. I've put 2 records in my table. So as I said, you could have just kind of separated them, 1 per line, but every time then you'll have to write these. So you could have only written this and then repeated it. Insert into table values this, insert into table values this, 1 record at a time. And then it will have a semicolon every time. Now this way, when I have more than 1 records, then please remember that records are separated by commas and the last one has a semicolon. Let's save this. I have some data in my table. Run the script. Everything looks okay. I don't see any green. And anytime you would like to clear, it kind of becomes very untidy very quickly. So whenever you want to clear this window, do a right click on action and say clear, right? That way it's easy to see. All green checks. So it's working. But now comes the big question, where is the data? You'll say, oh, why don't you open that window that you showed to us before and see if the data is in there? Remember, this is only showing you the structure. This is a navigator. It only shows you the structure. It doesn't show you the data in it. Which I can also see like this, just for information. I can also see the structure like this. We say display the structure. Let's display the structure of the table. Describe and the name of the table. You don't have to always open up the left-hand side window. Usually whenever you want to see the table structure, the statement is describe. Another thing that you can do, just for, if you want to display what are the tables. What are the tables in my database? Now I only have 1, but I mean, it's not a big deal. You can always say show tables. Right? So show tables will show you the tables in your database. Describe will show you the structure of the table. And we'll do it in a minute. I'll execute it for you. But now the most important thing, I want to see my data. Did the data go into my table? How do I prove that? So to display all the columns, because you may be only interested in seeing my name and email. But for now, I want to display all the columns and all the rows in the table. Again, I'm starting working with the easiest first, okay? And the statement is select. Oops, not elect, select. I want you to go star. Therefore, I said star. Star means all columns, okay? From the name of the table. And that's the last statement. Semicolon is not required because it's basically a separator separating one statement from the other, but I should call it separator, not terminators, because you can put more than one statements in the same line. So it's a separator, but if there is nothing after it, you needn't put it. But by practice or not more than just by habit, we just put a semicolon at the end of the statement. So there's a difference between terminator and separator. Separator means you could do this. You could put a statement right here. I'll just try to kind of write again just to show you. I mean, you can write more than one statements in the same line. And I'm okay. It won't say anything. It's a separator. It separates a statement, right? So for us, we just put them in different lines for neatness. I mean, human beings, we can kind of read so much together. So the last statement at line number 45 is simply saying, show me all the columns and all the rows in the table. Let's see if it works. Now I have a few things. So I'm just going to clear this, though it's not a big thing right now. Hopefully I won't have errors. I don't see any red squigglies. But remember, errors may not only be syntax errors. It could be logical errors also. Something could be wrong in logic also. There, I see my records. Notice the field names. That's the name. You can always increase it like this if you want. It's just a display, guys. It's not a permanent. It's not saving it anywhere. It's not doing anything. It's just a display on the screen. If you wanted to, you could put it. Oh, Google. Okay. I can't see it very clearly. The G is not coming up very clear. But there it is. That's my display window. My data is where it should. The sequence is important. I had exactly followed the sequence that they were in, right? If I make a mistake, if I take my age here, 50, and change it to Anju, which makes no sense at all. So that's a numeric field, and I've changed it to Anju and I run it. I'm going to get a syntax error. It says incorrect integer value Anju for column student age at row 1. So it's telling you where you find it. So you can kind of click on it, and this is the statement that is causing it, right? And then once you know what statement is causing it, you can say, oh, row 1 means this is what she's talking about. So you can make mistakes. Though you can do this, which I don't like it, but I can't help it. It's not, I'm not the person who wrote it. So Anju Chawla is text. I've written it. I'm seeing a red squiggly. Red squiggly means that it's not allowing me to. I need quotes.
All it says it's missing your closing parentheses or something.
Am I missing my closing?
No, that's just what it says. Like if you hover over the word.
Over the, okay, you have an error?
No, if you hover over Anju in the actual code, it'll tell you what it is. Like hover over your name right there.
Missing closing parentheses. Okay, so it's, okay. I thought it took it without quotes, but seems like not, which is good. But of course, 50 can go in quotes, which I don't want you to do, and it will work, right? I don't want you to do this. So numeric data in quotes works. It works. It is fine. But my rule is, and I want you to follow that rule. So as long as it is a number, you can put it in quotes and it is numeric, it's integer, it will work. But rule remains. It will always remain in all your assignments. Text data in quotes and numeric data without quotes. Now, what if I wanted a quote in my name, just for the heck of it? I wanted a quote here. As soon as I do this, Anju C stops because it ends. It ended it. What do you think I can do to avoid it? Or not avoid it, a solution for it. What do you think I can do? Backslash is the best option. The other option could be you change this single into double, which I said you can, though I don't like it personally, but you could. And then you can use a single quote inside. And you're good to go. That will work, right? But I just don't like the use of double quotes because it's all black and I can't read it clearly. But it's me, it's just me. Usually you will see that data is written in single quotes. But what if I needed a single and a double quote in it? Now I'm screwed. Like, what do I do? If it is single, I use doubles outside. If I need a double, I use single outside. But what if I want both? So why should we look for a solution that works halfway? You know what I mean? Like, so the best way to work is this. you escape its meaning. They are called escape sequences, if you remember from Java. Why are they called escape sequences? Because you're actually escaping what they mean. So they have a special meaning. The code has a special meaning in SQL. That special meaning is delimiting your data, right? It has a special meaning. If you want to say, don't go to its special meaning, just use it as a normal character, then you escape it and you put a backslash in. So any character that has a special meaning in SQL, I know about single and double quotes, you may encounter more if you work. All you do is you put a backslash in front of it and you escape it. So now there is no problem. You want a single one, escape it. You want a double one, escape it. Everything will work fine. Right? So these are called escape sequences. Backslashes are called escape sequences because what you're doing is you are giving it its normal definition. So a quote is a quote. But because specifically in relational database, it was used for delimiting data, I had to kind of say, don't become special. Just forget about your speciality. So I escaped its special meaning. So you can do this. So that's for your information, right? So if you wanted to, you could do it. Like it will look very odd, but my aim is to show you that it will work. So there it is. There is a double quote after the J, and there is a, it's kind of small, right? If I could see it and maybe increase its size somewhere, I should be able to give it more space. I will. There should be a small squiggly or something that shows me better. Anyway, so that's showing me the single quote and the double quote works. Now, what about the other two statements that I wrote? Show tables and describe. They should have outputs too. Please notice that there are 3 tabs here. This is showing the tables. These are the tables that are available in your database. There is only one called TBL students. That's what you expected. I only have one table. Then I said, describe my table. So that's describing your table. So what does it say? It says these are the fields in your table. These are the types in that table. They can all have a null value. We'll talk about null after the break, right? They can have null values. There is no key in the table. The key column is empty. We'll talk about keys also in the second half. The default value is null. You'll say, what do we mean by default? Default means if you don't give it a value, it is null. And anything extra will come here like auto increment and so on, which you will learn in the future. Here is the describe statement. And of course, here is your select statement. So there are tabs and you'll have to look at each tab to see what is going on, right? So when I said this is the default insert, let's show you something else now. What if you didn't want to insert all the values? I only want to insert, say, maybe the name and the email. Again, the order in which I want to insert or which fields do I want to insert depends on me. So now you can insert any number of fields. You can, or chosen fields or preferred fields in preferred order. I can do that. The insert allows me. So what I'm going to do is just to show you, I'm going to insert the student email first. And then I'm going to insert the student name. I don't want to insert anything else, just for now, right? So I'll take another record here. And so email first. So let's take Jarrett. Not sure if he has taught you in semester 1. I'm just picking up my colleagues, okay? Instead of making your information public. So that's the email and that's his name. Now, since both of these are text, I could have switched them, but keep in mind, the first field goes in the first. So there is a direct connection. The first value goes in the first field. The second value goes in the second field. So both are text. You could have written his name first and email afterwards, but then there is wrong data in the table, right? So you could make this mistake commonly just because, oh, it's text and you You just say name and email, but keep in mind that this must match. So there should be one-to-one match, right? So the field name should match field value. I hope you understand that, right? So if I wanted to add his age somewhere, I have to give it in that same order. I can't put it in any order I like. But this is more flexible. Flexibility in terms of you didn't want to add everybody's data. So what you did was you just kind of made a new insert statement, not new, a different form of insert statement. I'm just putting one record here. So when you put a record, you just put a semicolon after it. And this should work too. But now the question is what happens to the other fields? If you remember when I was showing you this result, it said that the default is null. For all the fields, the default is null. So let's see what happens. Let's run it. Save it and run it. And pay attention to the last record. And see what has gone in his other fields. The other fields are all null. A null is a special reserved value in a database, which basically means not defined. It's not empty. We're not talking empty here. Empty is different. Empty means you put it in single quotes, nothing in single quotes, or one blank or two blanks. An empty field is not null. Null is a special value, which means not defined. This field is not defined at all. But if a field is empty, I could put data in it like this, just to show you again for the heck of it. I could put, if I like, nothing in the email and maybe his name. And that's fine. But this is an empty field, right? It is a defined field. Whereas null is not defined. It's an undefined field. You can check, is the field null? You can check, make that check. You can also check if a field is empty. How? You can take the length of it and say, oh, the length is 0. You can trim it. I can put more than one blanks here, though I wouldn't, but I can always trim it. Trim remove is any extra trailing or leading blanks, and I can say, oh, the length is 0. But there's a difference between null and an empty field. Right? So let's try that now. See what happens. Please notice the word null doesn't occur under student email. It's an empty field. So empty is different from null. Empty is a defined value. Like in Java, it's a defined value. You can check, are you empty? Is the field empty? You can check if there is nothing in it. Whereas null says, I'm not defined. Don't talk to me. I don't have a definition. So that reserved word null, don't put it in quotes. If you put it in quotes, it becomes text. And text is just text. Like null is just null. You could call somebody null. Though it's not a good name, but somebody could be called null. So null in quotes is text, but null without quotes. You notice how it went? Have I used it anywhere? No, not yet. But I'll show you. I can show you. But null, you can enter the word null, N-U-L-L, and it is a reserved word. Okay, so there we know what now we know what is the meaning of default values. And please understand, we know that null is different from an empty field. And now you also know that you can enter whatever fields you want in whatever order you want, as long as there is one-to-one match. You're good, right? So that's another way of inserting statements, right? We'll take a break here and come back and do more of this. Yes. The syntax error. You see the semicolon wherever you're there. Okay, strict or table needs double quotes. The strict or table needs double quotes, not single quotes. You can start it. Okay, so just clear, go to action and action, right click and clear. This. So I'll send it to you. It's coming with some. Okay, let's do it once more. I still see. Okay, so there is an insert. There's something wrong in DB call. It doesn't exist. No, the name of the table is wrong. It says, bring your error code. It says table DB college dot TBL student spelling is wrong. Students. I mean, it will tell you there's another one that's wrong. You copy it.
Thank you. And then I was also wondering if I can switch to the Wednesday class.
You wanted to switch in the Wednesday class? Okay, make a change.
I'm not officially in yet, but then can I submit today's assignment today and then?
Yeah. The today's assignment will be, I think everybody will be given a day. So
Okay.
I don't think you'll be able to finish it in class.
Okay.
So it will be common for everybody.
Okay.
And then change your section on banner.
To go back to the road.
Did you try to get it?
I didn't do anything.
I have a question about the repeating data types. So we can have like two different things, like two different choices, say YouTube and Netflix and our favorite thing. But you mean like don't have YouTube and YouTube? Like,
No. Not that repeating. Repeating means the same kind of data.
Oh, okay.
So when I'm saying favorite sites, everyone is a site.
Yeah.
That's repeating.
Okay.
It's not the same site, it's just repeating. The nature of the data is repeating. They're all sites.
Right.
That's what repeating is. So you don't need that. We cannot have that. We should not have that.
It's just it's best practice to not have it.
Not have, it's a rule, kind of. It's the first rule of designing.
Right.
Whatever is in the first text box.
So exit, make sure you have that same. And now exit.
So, so this is actually just on this plate to calculate those. So, it's thinking of the correct way to do it. So it's actually. Yeah, this. Yeah.
Not map, just the match.
So you can see the link of the object.
Also, I was gonna say for this class, I would recommend for math students, there's a program called MAP that works very good.
MAMP, yeah, there is, yeah.
Because I didn't know about it last class.
Right.
So, yeah.
Yeah, I should have mentioned it because XAMPP is for everybody, but yes, for Mac people, there is only MAMP also.
Exactly.
Yeah. And that works much better than XAMPP?
Yeah, because there was an issue connecting with XAMPP and MAP is just very straightforward.
Okay, thank you. I will mention it. I know about it because some student told me last semester, but I forgot to put it on my blackboard.
Yeah, no.
Yeah. And I thought XAMPP was more generic because then everybody could use it, but definitely if you prefer MAMP. Yeah. Oh, yes. Thank you. I will put it on my blackboard.
Yeah.
There was another student was having an issue with XAMPP yesterday. MySQL would start and then would shut down immediately.
Yeah, I don't know. I remember I was Googling stuff and I got it to work at some point.
Mhm.
But MAP was just very straightforward. It's very simple.
Okay. MAMP, right?
Yeah.
Yeah. Okay. Thank you.
So you have to open up this one, sure. And this is where you change stuff. Okay, so you. Okay.
I'm still having trouble trying to install like the workbench. It's saying like I don't have this version, like the Microsoft Visual C++. And I try
It still
to,
says so?
yeah.
I had that issue. You have to, I can't remember what the term is, but you have to run it a certain way. So like, if you want to bring it over here. you go.
Okay. Thank
Yeah,
you.
you gotta, if you won't have full access, so like if we run into issues, I'll try and figure it out
Like
later
I
in the
tried
semester, but
uninstalling.
yeah, so I'll go.
It'd be nice to.
For this workbench.
I tried it.
Also, you can't even get it installed, eh?
So the workbench is not installed. Oh, I mean, you didn't even reach workbench is what you're saying.
You get it installed, like you get in there, and then it has that like pop-up that
Yeah.
says continue anyway or whatever.
Yeah.
Okay.
I uninstalled that previous version to install like another one.
So what do you say when you test it?
Yeah, I'll show you. It'll, once you do it the one time, then you only have to do it the once, then it connects after that. But yeah, you just don't have like, I don't have the performance and all that. I can't use any of that. So like if we end up having to use that later in the semester, we'll have to figure
Yeah.
something else out.
But
So,
why is it creating problems? Like, what's the reason that it is creating problems?
to be honest with you, I wasn't sure what. the
Like,
hell-
I've never had problems. I've been installing WAMP. Is that WAMP you installed to begin with?
Yeah,
Okay, so you know what? Maybe I can make it a point in class. If XAMPP is causing problems, people just maybe shift to MAMP.
Okay, so yeah, for that one, you have to go in your non-movie program.
Yeah, I did, but it's not showing up. It's like I don't have the 25th here. It's saying I have another version, but it's mine.
So let me look where MAMP is available and then give the website.
All of it?
I deleted everything, or hold on, I can show you what versions I got.
MAMP and MAMP Pro, right?
Yeah, and you just download
The normal MAMP?
the free one, yeah.
Okay, so let me take that website. And on Blackboard, and on Blackboard.
You feel it's a lot, but it's very
Which one are you trying to download? 2017? If you get rid of 17, yeah. That's what I'll show you.
You download 2015.
Probably get there. So now you got it. I try firing up my SQL. Yeah, I just got whatever it was there.
It's your username.
Or no, yeah. I do both. I just switch back and forth. So, I mean, that easy.
Yeah, I usually want 2015.
Yeah. It's my console's like I'm more used to first person shooters on, but this like because you can build and stuff like Minecraft, it's a lot easier to build.
Yeah, I set my keybones on my friends before.
Oh yeah, I do the same thing.
That's you, that's all I do.
Yeah, I'm not too good with the bursts.
That's good.
It's good. I suck with the bursts. I can't follow guys. I can get the first shot. That's it.
Been rocking that double pump.
I do. I'm heavy. Well, I'm doing chats. I know. Daquan just tears it up with it.
Okay, so
Does it work? Yeah.
What did you do? Let me know, because when I have students coming, then I don't know what to do. You know what I mean?
First, you just have to uninstall the latest version of CSS or Visual Studios and then get 2015.
Oh, the Visual Studio itself. Oh, so you had that on your machine
And then 2017, I installed it.
and go back to 2015?
Yeah.
Ah, okay. I have 2015, so I was okay. That means I don't have 2017 yet.
I don't think the workbench works with 2017 yet. And then 2017 screws 2015 up.
yeah, you don't.
Yeah, so the last one
Okay, so let's move forward and talk about other things now. So we now know what null is, we now know what empty string is, right? Can we assign the value null to a field? Definitely you can do that, though it's kind of an odd thing to do, but you could, and I'll show you how. You just use the reserved word null, like you can go null like this, right? So null is a reserved word, and let's go. There. So you can assign, if you like, the word null to a field that can have null values. So it is a reserved word, but don't put it in quotes. If you put it in quotes, it becomes text data. Okay, so it becomes an actual word, but null without quotes is just null, and so it's there, it's allowed. Now let's talk about a few more things or improvements in my table. One, let's see, and this will run. This should run. I don't see any squiggly lines. So Douglas Burton will have null in his email. And notice Scott McNindle has a blank in the email because they're two different things. One is defined and one is undefined. And the other fields where I did not put in data automatically became null because their default value was null. Okay, now let's try to make a few changes to the structure of this data as to what will make my table a little better, because that's the first thing, right? We have to kind of say, oh, it should be a good table, because designing is, as I said, very important. Let me kind of ask you this question and get input from you. What field or fields in this table you think should always be present? Otherwise, it makes no sense of that record. The record has no meaning. You know what I'm trying to say? What field or fields? Name. What's your name?
Tyler.
Tyler?
Yeah.
Okay, so Tyler says name. Makes sense to me. If I'm keeping information about a student, I better have his or her name at least. Right? Anything else?
Student email.
Not bad. Not very necessary, but not bad. A good one. Your name?
Noah.
Nova? Okay, so Tyler and Nova, two names are good for enough. One day, two, right? So I agree. Anybody who disagrees? Name makes sense for sure, because I mean, I'm keeping a record about a student and I don't even know his name. So what am I identifying the record by? Nobody. Email, I would go yes, no, but not a bad idea at all. So I'll stick to that. Are age, fee, job desired, and favorite sites important fields? No, not very. Right? So to enforce that these fields must always be present in a record, all I do is this. I add the not null option with it. Please again understand, not null is not empty. So the name can still be empty. So which is again like not good. But what I also want to bring to your notice is something else. Remember, this is the back end. I'm saving the data in the database, but the data was collected at the front end, maybe using a PHP form or a web page or something. It's their duty to ensure that name is taken. So when you fill a form, remember, if you can recollect that some of the fields have that red field is necessary, and you can never submit a form till you fill up those fields. So you should ensure, that's the point where you should ensure that the fields should not be empty, because here there is no way I can ensure, because a blank is a valid text data. But I can ensure that it must always be provided. There should be some value in it. The blank part I cannot ensure here because there is no way I can do it at this end. But you can ensure that at the front end. So assuming that the name is not empty, I can ensure this, that it is not null, which means that the name and the email are required fields. So not null means cannot be null, right? They cannot have a null value. If they cannot have a null value, that means they are required field. Same here, it's a required field. Which means when I'm going to run my code, I'm going to get an error. Why? Because I just added, if you remember, Douglas Burton with the null. Remember, I just added his email as null. I should get an error now. So let's try if I can do that. So I don't see any red squiggly. It's not a syntax error. I mean, null is a reserved word. It's not a syntax error, but I'm going to get a logical error now. And there it is. It says student email cannot be null. And it tells you in what statement am I getting it. Make sense? Right? So that's your first thing to understand. That if you like, and if you look at the structure, so I have an error, so it won't go on. So I'll you can do this. You can put a note for yourself. Why can't you do it? I was showing you before because I wanted to show you that null was different from a blank, but now I've said these fields cannot be null, so I cannot do it, right? Now when I run my script, I should be good. And if I show you the structure, notice how this column, which had yes, yes, yes before, now says no, no, yes, yes, yes. So that's how the structure changes. So this is a good way of looking at the structure of your table to see the changes that you are making sense here. So everybody now clear with what is not null? Not null simply means that these values must be provided. And which fields do you choose to say that these fields should be not null? You have to be an intelligent programmer. Like you just can't say, oh, I need the age. Maybe it's not so important. Or the client will tell you that these fields are necessary. Definitely. Maybe the registrar's office doesn't bother about age at all, or what your favorite sites are. They don't. If you give them good, if you don't, that's fine too. Or what job you desire. Maybe they're just fields that they want to collect information about, and it helps them for marketing. So, or it helps them to say, oh, this student chose this course because he or she wanted to be this. You know what I mean? So they could collect, and we do. Forms do collect information for marketing analysis. We do it all the time. But some fields are necessary when you fill up web forms. And that's what necessary means. You say that those fields are not null fields. Clear? One job done. 2. So we know what not null is. 2. There is another option that I would like to talk about. Sometimes, I'm just saying sometimes, but it could be many a times also. Some fields can have a predefined automatic default value so that you don't have to enter it. For example, so you're coming to Georgian, for example, in Barrie campus, and the college assumes that if you're in Barrie, you are living in within maybe 5 kilometers or 10 kilometers, something that you're a resident of Barrie or maybe Aurelia, something like that. So there may be a field called city, and it can have a default value of Barrie, which appears on the form, but you have the option of changing it, but it appears so that you don't have to put it in. So sometimes, as I said, it depends. You may choose to have a default value for a particular field. Just why? To make it easy for the user when he or she enters data, 1, and 2, when you write a script, you don't have to give a value for it. It will automatically take a default value. So you don't have to say, oh, I have to enter. So you'll use an insert statement. You can't use the one that says, give me all fields. There is not where you can use it. But in insert statements where you choose fields and you know that, oh, I can just leave it Barrie, there you can just ignore the field city. So here, I don't see something that's kind of very, you could say, oh, my students are coming from the middle school, so maybe the student age is 19. I'll kind of go this. I'm assuming my students are computer programmers. I don't see a very good example of a field that will work for a default here, but I hope you understand that it can, it's very obvious sometimes, right? Semester, for example, you're filling up the form and it's fall right now. And so the default is, sorry, it's summer. The default is summer, but maybe you want to join the college in fall. So if you want to make a change, good. Otherwise, by default, it will come as summer 2018, right? And that happens when you look for colleges and students tell their preferences. They'll say, oh, I want to join in summer of 2018, or some of may say, oh, I want to join in January of 2019. So what happens is the current semester comes up automatically and it can be changed. So these are called default values. Let's see how they work, right? Let's see how they work. So let's save this. And now let's run it again. And you will notice that in job desired, where I had not provided any values, it has gone from not null, from the null value, which was its default, to computer programmer. So if you don't provide it a value, it will take the default value. Right? Make sense? So that's what default is. Now, just for the heck of it, I could, if I like, I can say not null, I can combine the two. You'll say, what's the sense? The sense is this. All it is saying is you cannot give it a null value. That's all it is saying. You cannot give it a null value. So the advantage is you cannot give it a null value. You may not provide it in an insert statement. You may not provide it. That's okay. It will fill it up with computer programmer, but you cannot assign a null value to it in an insert statement. So they're kind of put together and you'll say, oh, I don't think they make sense. One is saying it is required and the other is saying here is the default. But keep in mind, all it is saying is you cannot assign a null value to it. But you have the option of not inserting it at all, and it will insert computer programmer, which are kind of two different things. So in a list, in this list, I cannot put null here. Wherever I said, oh, this programmer, she wants to be an educator or whatever, I can put null here. But I still have the option of not providing it. I didn't provide it here. So if you don't provide it, it takes the default value. But if you provide it, you cannot give it a null value, is all you are saying. So you can combine the two, right? So if I run it again, I should be fine because I haven't given it a null anywhere. But if I choose to do this, just for the heck of it, if I choose to do this, I'm going to take this insert statement. If I choose this insert statement and I add my third field, and that third field, what did I just make? Job desired, I think, right? I choose to add this field, and you cannot add more, you cannot add less. You exactly have to give 3 values. So if I try to do something like this, just to show you, just because I'm becoming lazy now, I gave it 2 values. You'll say, oh, it has a default value, so it will take it on its own. That's not how it works. The default value is not that how it works. You've mentioned in the list that you will give it. If it was not mentioned, then the default works. But in the list, you've mentioned it, oh, I will give it. So then if you try to kind of not give it, it will give you an error. It will tell you about, oh, count is, something is wrong in the count. Count is saying there are 3 here and there are 2 here. So if you mention it in the list, you have to give it. But what you can do is this. You can give it a null value. So if it is not in the list, here it's not in the list at all. It's good. It will take its default value. If it is in the list, you have to provide it. And it cannot be null. So I'll get an error again in this one. I've given 3 values. 3 to 3 matches fine, but I still have an error because it cannot be null. Right? So you can do this combinations of not null, default, and we'll talk a little more, but that's what it is. So it cannot be null. Right? This will give an error. So instead of here, job desired is traveling. Douglas loves to travel. There, travel. But you cannot provide null. You cannot give it a null value. So if you would like to kind of put, I'll just kind of put this because it's easy for me. What was it? Student email. I'm making the third as null. And I'll say job desired cannot be null, so that you know. Right? So try to uncomment it. If you uncomment it, you will get an error. But of course, then you have to be careful that this should be a comma. So if you like, I can just do this in a different line. That way you don't have to worry about the semicolons and so on. Right? So definitely this will not work. But to see that it doesn't work, you can always do this and you'll get an error. Right? So if I run this, I will get an error. There it is, cannot be null. So I'll comment this out so that you know. Anything that doesn't work, I'll leave it for you, but I'll comment it out. So that you can go back and always kind of say, oh, why doesn't it happen? I'll do the same here. So that way you can always uncomment it. So I can do this, like I cannot. So I'll put this in. Anything in comments is creating a problem. So this is creating a problem because email cannot be null. This is creating a problem because job desired cannot be null. Insert preferred fields in preferred orders. Field names should match field values. And if you like, now you can add this. Default values will go for. If you don't mention the field, it's okay. It's fine. You were saying I'm not putting anything into it. It has a not null with it, but it also has a default with it. So you'll say, oh, it's not null, I have to give it. But you're okay, you're safe because though it is not null, it has a default value. So default values for job desired or default values will fill job desired automatically. So it's not required, though it is not null. So it's kind of, you could say it's kind of complementary or contradicting, whatever you would like to say, but it makes sense. So not null says it cannot be null, but it has a default value. So it is required, but it fills it up on its own, right? So that's not null, and so you could combine them is what I am bringing to your notice. Now one more question. What field or what combination of fields is unique in this table, according to you? For every record, it is unique. Give me your best guess. Emails. I would necessarily not agree with it, but sure. When you try to put an email and it already exists, the email comes up saying this email already exists, right? So yes, email. Now with student IDs, with student everything has @georgiancollege.ca or something, and if they have the same name, then email may not be unique, right? I'm looking for 100% sure shot. I can't think of a field. You could say name, but though the probability is again very less, two students may have the same name. So name would be a little better than emails, but what the college does is, so that you know, if two students have the same name, which has happened in my classes, they just go, or for two instructors that have the same name, common, they kind of put a 1, 2 with it. So Anju Chawla 1, Anju Chawla 2 kind of, that's how it becomes. So they do take care of it, right? They do, because they have to make it unique. They want to make it unique. With names, I can't do that. With names, if somebody's name is Anju Chawla, then I can change their name. You know what I mean? I can. So from that point of view, you could say, oh, email can act better because you can ensure that it is unique. But I don't see 100% surety that it will work in the sense maybe it's the college doing it. That's fine, right? I know that on certain servers you cannot create the same email, and that's fine too. So email may act as a good primary key. More than name, email will act as a good primary key. Now, what is this primary key? We didn't even talk about it till yet. A primary key is a field, or it could be a combination of fields. So worst case behavior in this table, if none of the fields is 100% unique, I can say the combination of all the fields is unique, which simply means what? Oh, every record is unique, but completely unique, altogether unique. But that's the worst scenario. But a primary key is a field or a composite field. It could be made of 2 fields, 3 fields, 4 fields. It is a composite field that uniquely, it is unique in nature in every record, and it cannot be null. And it identifies the record in the table. That's what a primary key is. Sometimes you may have more than one candidates. Email may act as a primary key. Student ID can also act as a primary key. They can both act as a primary key in the college because, as I said, no 2 students even with the same name have the same primary key. They put a 1 or a 2 with it, right? So you may have more than one candidates, but every table only has one primary key. And by default, a primary key cannot be null and is unique in nature. It can be a single field or a composite field, but a table can have only one primary field, and its use is that it uniquely identifies every record in the table. It makes a record unique. And by default, an index is created on a primary key. So there's always an index, it automatically gets created on the primary field. So searching becomes easier. Try to always work with the primary key when you're searching for something. Why? Because it is unique. That's number 1. 2, it has an index, so the searching will be easier. Of course, if you're looking for all computer programmers in the college, you won't search on student ID. You will search on the program name. But if you can, if you have the option, always work with the primary key when you're searching for something, updating something, and so on, right? So how do we create a primary key in the table is now our next question, right? So now let me repeat, what is a first normal form table? A table is said to be in the first normal form. That's the minimum. If it has a primary key, 1, and it has no field that has repeating data. I'll repeat, repeating data. Nova came up with the question, what do you mean by repeating? That you don't say yahoo.com twice? That's not what I mean by repeating data. I mean the same nature data. So when I say favorite sites, every piece of data is a site. So I'll clarify myself. When I say repeating data doesn't mean the same data, google.com, google.com written 3 times or 4 times. What I mean is the same type of data, the same nature. They're all websites. You know what I mean? It shouldn't. Now, right now, I cannot take care of that in my table because it's more work. You haven't reached that stage. I can do this. I can create job preference 1, job preference 2, job preference 3. I can say that's maximum that I can allow you to give for job design. Maybe 1 gives 1, the rest of the 2 fields are empty. Not a good design, I'm wasting space. Maybe somebody gives 2, the 3rd is empty. Again, I'm wasting space. So that's not the best solution, but I could do that to make it non-repeating. But I have to make my judgment. Do I need 1 job desired? Do I need 2 of them? Do I need 3 of them? Do I need 4 of them? I have to make that decision. And it could be a good decision because usually people say job desired. I could be saying, what's your first, second, and third preference? You just choose not to give the second and the third preference. Similarly with favorite sites, I can say, okay, I'm going to ask for 5 favorite sites. Maybe some of you don't even enter 1, or you only have couple. So it's not the best solution. So there is a better solution, which we will learn in due course. But at least I can take care of primary key. I can do part of it. which is not how it works. You don't say, well, I have done half of it, so it is okay. Right? You can't do that. But we will learn how to do that. But I'll tell you how to create a primary key in a table. And primary key is a field or a group of fields that uniquely identifies every record in the table. And it is a partial requirement of a table to be in the first normal form, which is the minimum requirement in the designing of a table. Minimum, the first requirement. How do we do that? I'm going to save this so that I don't disturb this. And I'm going to save it as another script. I'll put both of these on Blackboard and I'll call it with PK. I just put PK with it. So it's Thursday, yes, okay. And I'll change the purpose. Create a database, a table therein to store information, select data. Let's say create a primary key. It's called primary key. You can go PK for short ones. I mean, I'll go for short. Instead of create, I'll say add a primary key because we don't create them, we add them. Right? Let's see how we do that. So I'll kind of keep things the same, but I'll remove all those examples that of insert that I did because those are not important to me anymore. To me, the primary key is more important. Okay, so what do we do? There will be no changes in kind of creating and so on and so forth. But what I'll do is I'll create another field here. Now, it needn't be the first field, physically the first field of the table. There's no rule about that. It's just there, okay? I'm going to call it student ID. We all agree that student ID is a good primary key. It's always unique, right? Now it's type. I won't go with integers or long integers because I'm not going to do any math with it. It doesn't make sense to work with numbers if they're not numbers in a sense, like phone numbers, right? So I'm going to make it a character field. Why do I choose character? Because usually, not usually, almost 100% of times, it's of a fixed size. Like all your student IDs are of a fixed size. So I could have said varchar 10, nothing, it's not wrong, but char 10 is a better definition. Why? Because you're kind of saying every record, it will be of size 10. So does that ensure that you have to enter 10 characters? No, it doesn't ensure that. There is no insurance there. It's just that it gives 10 characters for every one of them. So you can't put more, you can put less, which is also varchar. So there is no surety that you will enter 10. Then where is the surety done? Again, at the front end. It's the front end programmer who will ensure that when you're entering your student ID, you exactly give 10 characters. And if it is not 10 characters, then it kind of says something is wrong. Like it does when you try to log in, right? Same kind of concept. If you don't enter your student number correctly, it tells you your student number is incorrect. Or the other option is, okay, let it come, look at its length. There is a length function. If it is not 10, you delete that record. It doesn't work. It's not the right data, right? But that's what I've done. And how do I say it's a primary key? All I do is I add the word primary key in front of it. That's all I do. By default, it is not null. You don't have to say not null again. By default, it is not null and unique. Both options. Both options. It's not null and it is unique. That's what its option is. You don't have to worry about it. Now, this is MySQL. I'm almost positive Oracle also says the same way. It is not null and unique. But if not, if not null has to be added, you will just add not null primary key. You know what I mean? Like if it is not, but it is unique everywhere. And just because we are talking about uniqueness, unique is another thing that you can use with a field. You can say this field is unique, and then you cannot enter duplicate values into it. So not null can work separately. Unique can work separately. The combination is called, you can just say not null unique, but the combination is automatically available in primary key. But a table can only have one primary key. You should remember that. A table can only have one primary key. Not more than one. You can say, oh, this is also primary key, this is also primary. It can have a composite primary key. Combination can make a primary key. For example, first name and last name together. Suppose you had two fields, first name and last name, and you are saying names are unique. The combination can be a primary key, right? So a table can have only one primary key, though it can be composite. When I say composite, that means it can be a collection. If you had two fields, first name and last name, and you were 100% sure that names are unique, then you could combine them together and you'll say, how do I combine them? There is a different way of writing it. That way you do it here. Just so that you know. You kind of write it. You can also write a primary key like this. This is another way of, so don't write both of them, of course. You can also do something like this. So you can either mention it here. So usually when it is a single field, it is written in front of the field. When it is a composite field, then you write it here and then you put a comma and then you mention all the fields that together make the primary key. Then you cannot write it in single, because if you write it in different lines with each field, it says, oh, all these fields are primary keys. That cannot happen. So when it is a composite primary key, you write it at the end, primary key, and you kind of give that combination. If the field is a single one, then the practice is to just write it here because it's more readable, right? So I'll follow that one for now. When we come to composite primary keys, eventually, maybe in some example, then I'll do it. But for now, we are talking about single primary fields. So there can only be one primary key. Okay? Excuse me. Now you've learned about primary key. Let's see what happens when I try to enter values in a primary key. So what I'm going to do is I'm going to kind of remove all that I don't want. I'll remove this odd ones, Anju Chawla, which is looking odd here, but you learned about this in the other one. Right? Now, if I try to run this, of course, I'll get an error. Why? Because I need 7 fields and I only have 6. So column count doesn't match. Make sense? When I use a simple insert statement which has no field list, then I need 7 of them. So where will I add it? The position is important, so I'll just add it here. So I'll go 1, 2, 3, 4, 5, 6, 7, 8. How many did I say? 10? 10. Right? I've added it here. Just because it is easy, I've added it this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've added it here. You'll say, oh, that's a job. But that's entering student IDs. Data entry is always a job. Like it's the most boring job. But it is a job. You have to enter data to automate it. So if something could, but that data has to be entered somewhere, whether it's in a Word document, whether it is in an Excel file, whether it is in a text file, wherever it is, it has to be converted and still put it into the table, which can be done automatically. But first time the data has to be entered somewhere. So you can't avoid it. Though, I'll tell you another way of how to make primary keys. Now, this will work. There it is. Now let me try to do something else for you. I'm going to insert data again. And I'm going to put null for myself, just for the heck of it. And semicolon will change to semicolon. Okay, so I'm now doing an insert statement with null. And I hope you know this will not work because I'm putting null in a primary key field. Let's try it. It says student ID cannot be null. Make sense? Student ID cannot be null. So let's put that in comments here. So I've proved that to you. I didn't have to kind of write that separately. Now let's try this again. I'm going to insert the same ID. You could change this name just for the heck of it. Though it really doesn't matter. I mean, it really doesn't matter because I'll get an error anyway. Just replacing it with my daughter's data. Just for the heck of it. I mean, it could be the same record. The problem is not with the rest of the data. The problem is here. The problem is here. Let's try this. It looks like a normal record. It has 7 fields. Everything looks okay. I have an error. What does it say? Oh, the error is something else. It says you have an error, but that's not the error I want to see. What have I missed? One, two, three, four, 5, 6, 7. 7 fields. Did I miss? Oh, there it is. Semicolon. Because that's not what the error I wanted to see. The semicolon was missing, right? Okay, let's try it again. I want to see that duplicate key is not allowed. There it is, duplicate entry. Primary key cannot be duplicated, it has to be unique. So I've proved it cannot be student ID cannot be duplicate, has to be unique. I'll put this in comments again because it's not running. What do you think about the default with the primary key? Logically, what do you think about a default with the primary key? Does it make sense or not? If I leave it out once, it's fine, it gets a value, but I can't keep leaving it out because then it becomes duplicate. So default with the primary key, it doesn't make sense. Maybe it will work for a time, once, but not again, because it will give it the default value, and if the default value is unique in nature, it will be fine. But if I try to do it again, then of course it will say it already exists. So I haven't ever tried it, but maybe it will work once. Because it doesn't make sense to me that I have a duplicate key, that I have a default value for a primary key. Okay, so that's about primary keys. They are unique, they are not null, they identify each record, they have to be provided. Everything looks good. And usually they are characters, but it's not a rule. It's not a rule at all. I chose student ID. I know they're all numbers for you, but I can't assume it. You know what I mean? Like IDs can have something like GC in front of it. They could say something, or maybe the semester you joined, S for summer, F for fall, winter, it could be anything. And even if they are numbers, though, because they are numbers for you, I chose not to make them integers or long integers because it doesn't make sense. I will never do any math with it. Why should I tell the system to do extra work? Saving strings is the easiest way of doing it. It's the easiest. It may take more space because every character takes a space, right? So there, maybe the integer is taking 8 bytes and here I'm giving it 10 bytes. Character 10 means 10 bytes. But still there's nothing to be careful about it. You know what I mean? Like it's just text. So that's what it is. So sometimes data that sounds or feels or looks like a number may not always, it's not always an idea, oh, it's a number, I'll save it as a number. Just as a bypass, before I give you your assignment, just as a bypass, there is another way you could create a primary key. Another way. Now here I could find a field called student ID, which was quite a good field for a student, always exists, is unique in nature, cannot be null. Every student has an ID. Works fine enough, nothing bad in it at all. There is another school of thought which says if you cannot find a field in a table, or even if there is a unique field in a table, there is an easier way of creating a primary key. I don't agree with them on all of it. Yes, if there is no field that can act as a primary key, then I agree. Okay, let's make it automatic. But if there is a field that uniquely identifies every record, I would like to stick with that. So if I have a student ID which I know can act as a primary key, then I will choose not to do a default automatic primary key. But just as an aside, we will do it in due course. Just as an aside, you can make a field auto increment. You can say it is an auto increment primary key. What happens in that case is that by default, when you add a record, the first record you add gets the primary key 1. The second you add gets 2. The third you get 3. And it's an integer auto increment primary key. So you don't have to bother. Every field will be unique unless you mess it up, unless you try to insert a value that already exists. But usually when it is auto increment, you don't touch it. The system automatically gives it a number by default, right? You've seen it many places. You can see it in banks when you go, or wherever you need to have something, like if you go to the airport and do your parking, those numbers are automatically generated. Your ticket numbers are automatically generated for parking. I mean, nobody's saying that's how I identify you. The identification is that number. You go in, when you come out, you have to pay. It identifies you by the number at the time. And there you go. Right? That's how it identifies it. So there exists a way in which you don't have to think of a primary key. You say, let the system do it. All you do is I'll just show you how you do it. You say primary key and you put auto increment in front of it. It automatically, when you insert records, it goes 1, 2, it's an integer field 1, 2, 3, 4. But my thought is how useful are these numbers in identifying a record? For a student ID is useful. I can go to the registrar's office and I can say, can you pull out the records for student ID 100? Makes sense, right? I'm identifying the student. But how do I know what is record number 100 in my table? Because that 100 number is just a random 100 number in the table. So there are two schools of thoughts. Some programmers say, even if you can find a key, use auto increment. Don't even bother. Why are you bothering? My school of thought is a little different. But again, I leave it to you. You can read about it and you can kind of decide. But if a primary key had to be made, which was auto increment, this is all you would do. I'll put it in comments, but this is all you would do. You could call it anything you like. Usually it's called ID because that's what it does, identification. It has to be an integer. It can be a small int, a big int, or whatever, but its type has to be an integer. You can use int, integer, short int, whatever. It has to be an integer. Of course, you should be making it unsigned. But again, you don't have to. You can start with -300 and say, oh, start with -300. So default, it starts with 1. But you can say start with -300 and it will go -300, -299, -298, and so on. So I'm just giving it in its easiest form. And all you do is this. You say auto increment. Notice how it goes in small. It's just that because I don't write it in small, I better start doing it because it's easy for me to. I don't have to keep changing. And you put the word primary key in front of it. Of course, you can't have two primary keys. When I try to run this, Hopefully it will give me an error. I'm hoping. Multiple primary keys defined. So a table can only have one primary key. I've already told you that. But this is a way in which you could, if you like, create an auto increment primary key. Then you don't have to bother at all. You add, what do you have to add? You have to add these 6 fields or whatever, less or more, whatever is not null, and automatically it generates a number for you. Starts with 1 by default, will go to 2, will go to 3. You can delete records if you like, but those deleted record numbers, like if you delete record number 10, 10 will not be reused again. It's gone forever. And it can go on and on till the limit of integer. If you make it unsigned, then its limit will increase. 65535 records, you can say. If you want to go long int, depending upon how many records will be in your table, you can go long int and so on. But this is one way of doing it. And as I said, I personally am not a fan of it. I personally am not a fan of it because I don't find it identifying anything. I don't find it saying, oh, it identifies a student. Right? That's my thing. But maybe the college does it that way. As students join, they give them an automatic increment key, and that becomes your student ID, which is fine. They don't want to create a key every time, or maybe they have a software program that is creating a key. Hundreds, they have a different kind of a student ID. They look different. They don't have the 20 something in their. They're doing some combination that tells this student was studying here in 1999 and the student came in the 2000s. So there is something. Maybe they're generating it using an algorithm, but they're not manually inputting it, I'm sure. But yes, they could do it this way. They could say, okay, start the first student ID. They could start with, if they want it for 10 characters, they can start with 1 and 9 zeros. That will be the first one. The next will get 1 more, the next will get 1 more, the next will get 1 more. And that's fine too. So they have been generated automatically because that's fine. After that, of course, when you go to the registrar's office, you say, oh, here is my student. And that's perfectly fine. Right? So that's another thought, that you can generate a field automatically. And I agree with that point of view. It will depend upon the application. It will depend upon the application. So they're generating it automatically, and then it becomes your student ID, and it becomes you. And that's how you are identified. So it can be done. If you cannot find a field, or you are lazy to find a field, or as I said, some programmers say that's the best way of doing it because you're not poking your nose, let the system do it for you, then you can generate primary keys like that. Okay? So that's about what I wanted to talk. We haven't finished, we just started. So you'll learn more and more of it. But I think I've talked about primary keys, not nulls, defaults, unsigned, best fit. These are what kind of I wanted to talk about for my first lesson. Right? Now your job. We still have, if it can be done, it's not as if it cannot be done. It is doable. It is a half-hour work, not more, no less. But what I'm going to do is, I'm going to give you your, give me 1 minute, okay? I just want to check something. So I'll put this on Blackboard. I'll put this on Blackboard. I just want to check something. I'm checking if my solution is right before I give it to you. Okay. Okay, that's fine. Okay, so I'll post this on Blackboard, but I want to discuss it with you before you start doing it. Just small things because it's your first assignment. Oops, sorry. Because this is your first assignment. (2018). There it is. Here. It is 2018, right? Yes, it is. Okay. So nothing more that I've asked, but I leave it to you to make it, to do extra things if you like. And whenever you do anything extra, make a point for me and I'll give you bonus marks. So it says create a well-documented script. Well-documented means with comments, including your name, date, and purpose at the head. And the purpose doesn't say assignment number 1. The purpose says what your assignment is doing. Please keep in mind. At the head, following consistent naming conventions, whatever you choose, but consistent throughout your script. The script should execute correctly without any syntax or logical errors. Otherwise, you know what you will get, right? I mean, I can only give you what I see. The script should drop the database if it exists. Oh, why is it saying exists is wrong? Okay. Oh, well, right? Exists means, I'm saying if exists because you may be calling, many of you may call it the same, and then when I rerun, I'll have problems. So I want you to drop it, okay? And then a table therein that stores information about drinks. Nothing new. You say you did a students table. I'm telling you to create a drinks table. The table will contain information given below. Choose appropriate field names and ensure that the data type must of the best fit. It has marks, right? Best fit has marks. Comments have marks. Code, of course, has marks. As evident from the data, you'll say, how do I know? Because I've given you data. Cost, carbs, and calories are numeric fields. So I've told you cost, carbs, and calories are numeric fields. I've already told you that I want them to be numeric. They're not for just information basis. I want them to be numeric fields. Because you could say, oh, maybe it's just information. What math will you do with it? Don't worry about that. Just follow my instructions. Permitting only positive values. That means they cannot be negative. So you should know how to ensure that they are not negative. Okay. You'll say, what happens if I try to put a negative value? I'll show you what happens when you try to put a negative value actually into an age. So where was that? Here. So my fourth field was -50. Let's try to put a -50 in my age. I said it was an unsigned field. Do you see it's out of range? That's its use. If you say it is unsigned, you can put a negative value in it. Otherwise, what's the sense of saying it is unsigned? So it becomes out of range. So it is important. It is important right here. Okay. So I've told you that it can only have positive values. So you should know how to ensure that it is positive. That's your job. Cost should store values with 2 places after decimal. I've told you that though you should know it by default, cost means money. It should be 2 places after decimal, but because it's your first assignment, I'm just giving more instructions than I usually would. And carbs with only 1 place after decimal. So you will see that here some carbs have 2 places after decimal. Don't worry about it. Enter it. It will automatically strip the second off. You define your field properly. I have said I want to store it. When I say I want to store it with 1 place after decimal, I want to store it with 1 place after decimal. Don't worry about the data. Put in data, it will just remove the extra in numbers. Not in names, but in numbers. For example, let's try this again just to show you. Just for the heck of it, I'm going to make my student name as varchar 5, right? Just because 5 is too less for Anju Chawla. Let's try what happens. Data too long for column 1. Make sense? right? So I cannot save. So if it is 5 here, it cannot be more than 5. Though the vice versa is true. Now the vice versa, where can I show you the vice versa? Okay, so maybe I can show you here, 7, 2. So let's go 505. 3 places. I've given 3 places after decimal, right? What will it do? It will just truncate the extra 5. So anything extra there, it truncates it. But in math, it does. It says, you said, I want to store it with 2, I'll store it with 2. But of course, if you go out of range, so let's go 1, 1, 1. Is that more than 7? Definitely more than 7. The total is more than 7. Let's see what happens here. There it says it's out of range, right? But after the decimal, it kind of truncates. So that's okay, but the total is creating problems. So you just have to kind of work with it a little to see, oh, what is working and what is not working. Okay, so coming back. So I'm saying I want carbs with only 1 place after decimal. The data has 2 places after decimal. Don't worry about it. But your total length should be okay. That's what you have to think about. The total length is important, right? All fields are not null. So I hope you know how to make your fields not null. Don't forget the statement set SQL mode strict all tables is in double quotes if required. Now I say if required because I have noticed that with recent versions of MySQL, like now what we have 5.7, it doesn't create a problem. Though in 5.5 it was a requirement, but now 5.6 and 5.7, they're not even needed. They're not even needed. They have changed it. I still put it because I want to draw your attention to the set statement. You may not even need it, right? And it also depends upon the engine you are using. I may be using InnoDB, you may be using IXAMP. XAMPP and MAMP, I don't know what their engines are. If you notice, if you remember, I showed you that my SQL engine that I am using, the default engine for my case was my IXAMPP, or if I'm not mistaken. If you remember, somewhere we saw it. So my language is English. There is where my data is going. You should see an engine also. My port is 3306. My password, I don't have a password, but somewhere, default engine, here. My default engine is my IXAMPP, and it's working fine. It works fine. I can remove that set statement and I'm okay. But maybe on XAMPP or MAMP, it is something else. InnoDB is another one. And maybe then when you give me your script, it was running on yours, but it doesn't run on me, or vice versa. So that's why I always keep it. I always keep it to be safe. Okay. Read about it if you don't know what it is. For me, I use it because otherwise sometimes not null does not work. That's the use for your information if you hadn't read about it, right? So I keep it. So therefore I say if required here, because some students will say I don't even need it, right? We have discussed all this in class. We've gone through all this in class. There's nothing new for you. Then populate the data with the data provided as given below. Don't make any changes. So enter it as I've given you, because I want you to kind of see, oh, there was 6.1 here and it changed to a 0.6 because there is only 1 place after decimal. I want to bring it to your notice. Okay. So when you look at the size, you will look at the maximum size here. I see a maximum size of 4 here. So you will go with 4 because that's what your data is, 4. So you can go 3 because you have, though you'll say, oh, I only need 1 place after decimal, but the data has 4 places. So I just showed you, you can go beyond the 7, though you can go in the extra part of the decimal, it just removes it, truncates it. So you have to kind of look at these things. Should you choose 4 or 5? I wouldn't go with 5, though a little padding is not wrong, but 4 is good enough. Like I don't see anything greater than 42 here. So that's okay. And I need 1 place after decimal actually only to be on these, like that's what I've said. So 3 places before decimal, I'm still allowing 3 places before decimal. I don't see anything even near to 999. So why do it? So go best fit, okay? there could, I'll kind of give you an idea, but it's up to you. Notice how ICE has Y or N, yes or no. But I want to keep it as Y or N. Now you could make it a character 1 if you wanted, but then you can also enter A, B, C, D, E, F, any character, question mark, whatever. Think if you can think of a better one. There is no Boolean data type in MySQL. So think if you can think of a better approach, and if you can, I'll give you bonus marks for it. Otherwise, character 1 will of course do. Right? So I leave it to you. Anything extra? Don't make any changes. Insert text data in quotes and numeric data without quotes. So with quotes and without quotes. Or in quotes or without quotes. Add a select statement to display the data. I of course want to see that you inserted data. So please put a select statement at the end. And here is the data. How do you submit? Call me over so that I can see the script running, which may or may not happen, which is okay. Rename the script ICA1 your name, add your name to it, .sql, and submit via the assignments, in-class assignments ICA1 link on Blackboard. Okay, so all this will come on Blackboard in 5 minutes. So you can start working. Of course, you can't see both things together. So give me 5 minutes. I'll put it on Blackboard. You can start working on it if you like. You only have 10 minutes, but it's up to you. And I'll put it on Blackboard. Have you understood the assignment? Right? And it's Thursday today. It will be due by tomorrow midnight. More than enough time for you. Okay, so just let me very quickly put it for you. And I think it may already be there, but I'm not very sure. So I'll put the due date, don't worry, okay? Just give me 5 minutes, I'll put it, and then you can, I mean, of course, I'm not sure. At that point of time, I was saying you could, but who knows? Okay, so that's not it.
Just had a question.
Sure.
For the week of June 6th, or week of June 6th to 10th or whatever, I'm not going to be here. I'm going to be on vacation. I just wonder if I was going to miss anything.
Okay, now what is this vacation about is my first question. Out of the blue?
It's a family vacation.
Okay. So now if it's a vacation and there is nothing urgent or there's nothing that you had to go at that point of time, if there is an in-class and you miss it, you miss it. Okay? If it's a take-home and you can do it, you can do it. Okay?
I just wondered, I switched to the Wednesday section during the class, and on my Blackboard, I'm now also in
There is only one section on Blackboard, so don't worry about it. Yes, I've combined those sections, okay? So you should see, you are seeing a section. Yeah, you are seeing a section. Okay. So I'll put it up. It will be up for you. I'll put an announcement and you will know that it is up and the due date is tomorrow. Okay. I thought I would just do it in class and open it up here on the thing, but seems like I have to.
Google it, if you have it there.
I'll provide you with the rubric also so that you have an idea of what I'm looking for. Yes. No.
So, since this assignment's due tomorrow, do we have to show you it?
No, you can't, right?
Yeah.
I'll
Just
remove
wanna
that.
make sure it's like what you
Yeah,
want,
you're
so
right.
it's
So what
all-
I'll do is I'll change that, okay?
Okay, thank you.
Yeah, you can show it to me running, of course. So I'll change that before I put it up on Blackboard. Thank you for pointing that out. Otherwise, people will say, how do I show it to her? I'll remove it that you have to show it to me running because it was an in-class assignment, so.
It was almost a little too like I was aiming for that. But it is fairly simple. I don't know. Like, I haven't really found it.
I think it's gonna be a lot like Palmer.
I'm trying to do a Java. It's the exact same thing as Java. Code the interface is gonna pop up and stuff.
Oh, yeah, but
Rather
instead
than just click it.
exactly.
But, I mean, if that's the way they do it, that's fine.
Yeah,
I'm not gonna fight the industry.
yeah, I don't even know. We're also gonna include it in Java, so I don't know if we make the difference from like Java.
Yeah. Well, on NetBeans, I know it literally was almost the exact same thing.
Oh, yeah.
Yeah. It was really weird. That's why I never touched it last semester. Because I was like, that's the only crap I can find in these ones. It's yeah.
Yeah, I'm not ready to look because I'm using Eclipse right now. I'm a little bit scared that something's gonna come up and I'm not gonna know how to do it.
Yeah.
I have to get a PC man.
Why does NetBeans not work on
And
that?
that thing doesn't work on mine. There's a way to make it work, I'm sure.
I don't understand like why. Yeah, it's not like Mac just like why there's not more cross-platform stuff.
Yeah.
Beyond me.
Yeah.
But there's always issues.
Yeah.
Or every app is cross-platform.
Here, we're not trying to open it from here.
Yeah, that's true.
Like,
Although,
it
yeah,
shows-
for certain things it's changing now, because like.
Yeah, that's a warning. That's okay. Sometimes it comes. Don't worry about it.
but afterwards it should, it comes.
Maybe you don't have a connection then. Do you have a connection? Can you see your schemas here?
You
Yeah.
put it into this thing.
So open it from here. I would recommend
yeah.
open it from here.
From there it works. but
Yeah,
from
but I don't know. Like I've never
Yeah.
tried it from outside. I always try to open it from
Probably
here,
for
okay?
applications and web stuff. Yeah, it's still pretty like, it's interesting. I completely forgot what it was saying, yeah, because but yeah, man, it's some next other stuff, bro.
That's awesome. I'm sure we'll come across it. I'm kind of hoping we do more JavaScript instead of PHP. But she said we're like only doing PHP.
Yeah, that's the one thing, even he said, the school doesn't do a lot of JavaScript.
All the school doesn't at all.
We're not at all.
And I don't know why it shows you
And
some
it's actually
errors.
one, probably.
Because you're
for web
missing
development, it's the most
The
important
value
thing.
statement, there is no values yet. You haven't completed the insert into.
All back and never touched PHP.
Where is the record you want to insert?
Okay, I forgot to remove. Okay.
And like JavaScript, like there's so many other things.
Oh, you should be okay. You're fine now.
It's still showing the.
Do an action, clear the window. I want to see.
And didn't ask you what, just for content creation?
I got her.
Yeah.
I have no idea. to be honest.
I was kind of curious.
Yeah, I don't know if it's like.
What does it say?
Stuff.
Can't connect.
probably-
It's
I'm
not
thinking
connecting. The
graphics,
connection
but
is,
I'm-
there's no
like, I wanna
connection.
ask her if she does, like,
No, it was
content
working.
writing.
So maybe it just died or something. Don't worry. Close it and open it again. No big deal,
Okay.
right? Is your RAM, what are you using, WAMP or XAMPP?
Vamp.
Show me if it's running. Here it should come in your status.
Oh,
Yeah, yeah,
Read.
exactly.
Okay, just open the workbench again. Don't worry about it. Sometimes it happens.
Yeah, exactly. Yeah.
Let's see what happens, okay? It's not connecting, that's all.
So I was just gonna quickly ask then.
Sure.
If I'll be able to access it all the same.
Absolutely.
Yeah? Okay.
No big deal.
Fantastic. Thank you.
No problem.
Have a good night.
Good night. What does it say?
And it doesn't show this icon.
What do you mean by icon? Okay, so it's not connected. Go back to your home. Something is not working properly. Maybe you've lost connection. Do a right click. Do an edit. It's just not a big deal. Sometimes connections are lost. Do a test connection. Okay, so there is something, it's not just working. Don't worry about it. It's not as if you've done something wrong. Maybe it's just the network. Okay?
It's
It's
just
the network.
issues you
Yes,
have.
yes.
Okay. Thank you.
Most welcome. No big deal.
Bye.
Bye. Take care. You have a class here?
We do.
Come in, please. I'll leave.
Is that okay?
Yeah, of
So
course, of
pushing
course.
you out.
No. I didn't know that.
No, that's okay. Are you going to be here Thursdays for the summer?
For the summer, yes.
Yes. Well, we're following you otherwise.
Okay. I'll move out of your way.
Yeah, no problem.
I didn't realize it. Because once you finish, you just kind of,
Yeah. Oh, understandable.
no, I will in time. Usually I see people outside and you can see somebody, but
Yeah, when we
I,
sort of have to
yeah.
just around the corner.
It's strange that it is giving me. You know what? I'll complete it in my office.
I'm truly grateful. I'm I was, well, you weren't able to